Hello everyone, this is Zahid Bashir. I am a professional data analyst, and today I am going to discuss the second day part of Smart PLS 4. This is online training on Smart PLS 4. It is the basic level, and it is day 2 for the training session on Smart PLS. It is 6 March actually. Basically, I would like to recap the yesterday session first, and then I would like to proceed it further. The timing is same 5:20 p.m. to 6 p.m. Today is actually the 6th March. Myself, Zahid Bashir, faculty member at Department of Commerce, University of Gujarat, and a PhD scholar at Delhi College of Commerce, University of Punjab, Lahore. So let's recap what we have discussed yesterday. I was discussed about my introduction, the participant introduction, the course content, the method of assessment, the software download and installation procedure, and some of the parts from the basic environment and screen layout familiarity. If you missed that video, you can see that video from my channel, which is Research PDR. Uh, you can see my channel. So here it's a recap of the overall contents of small PLS training that I have discussed yesterday in greater detail. So if you would like to see, you can stop this video and you can see the detailed content. I have discussed them in yesterday. There are a lot more content relating to smart PLS that we will cover during the training of smart PLS. So these are the contents that we will cover. Then let's start what would be today for us, because we have also discussed the SEM environment, PLS SEM environment yesterday. So today we may have a brief session on different prerequisite or terminologies which are being used while applying structural equation modeling. So, what is SEM or structural equation modeling? Why it is used? What are the approaches of SEM, like CV-SEM versus PLS-SEM? What are the key components of PLS-SEM? Uh, Benefits of using Smart PLS 4 for SEM, and model fit indices for PLS-SEM versus CV-SEM. I actually will discuss the SEM, why it is used, approaches, key components, and benefits. Well, I will discuss the fit indices in tomorrow's session. So let's start from what is SEM and why it is used. Structural equation modeling is a statistical method that is being used for analyzing the relationship between observed variables and latent variables. By observed variable, we mean basically the indicators or the factors which are basically measured through some statistical scales like Likert scale, 5-point Likert scale, 7-point Likert scale. So whenever a statement or an indicator or a factor is measured, it is called observed variable. And latent variable is basically a variable which is not directly measured by any statement or any factor. It is basically indirectly measured by the observed variable. So as a first step, you need to have some observed variable or factors or indicators. Then you may be able to compute your latent variable on the basis of observed variable. So it is a comprehensive approach that combines aspects of factor analysis and multiple regression analysis to examine complex relationships in a model. Its purpose can be multifaceted, but some of the key objective and purpose of using SEM includes it will help you in model testing whether there is a theoretical relationship between the variables or not, whether your indicating paths are significant or not. It helps you to assess the fit of the proposed model using the observed data, thereby evaluating the validity of the hypothesized relationship. Then you may confirm whether your relationships, your hypothesis uh, are validated or not, whether your hypotheses which are derived from theoretical framework, whether they are confirmed to be accepted or not. Then you may have exploratory analysis. You can explore the potential relationship among variables in a data set. It allows researchers to uncover pattern and associations that may not be apparent through traditional statistical methods. Then, what is SEM and why it is used? You may use SEM in order to graphically consider the mediation and moderation analysis. Previously, mediation and moderation analysis is basically done using process by Hayes in SPSS, but the SPSS does not provide any graphical mode of considering the mediation and moderation. It just provides the conceptual approach of testing the process by Hayes for mediation and moderation. But Amos and Smart PLS basically provide the graphical approach of mediation and moderation analysis. So SEM enables researchers to investigate mediation and moderation effects among variables. It helps to understand the underlying mechanisms through which independent variable influence the dependent variable and how the strength of these relationships may vary under different conditions. Then we may have a model comparison. Structural equation modeling applies different alternative methods in order to determine whether your model is best fit with a particular method or not. So you can compare your model, you can compare your data with a particular model. If a particular model provides best values or best model fit as per comparison, you can use those models. It can also provide uh, uh, theoretical competition between different models or different hypotheses. Sometimes a hypothesis may be showing a positive relationship between two factors, and sometimes it may show a negative relationship between two factors according to some other theory. So how that theoretical relationship is being tested here, you can compare the model comparison based on different approaches. Then you can confirm your factor analysis procedure using the structural equation modeling using SEM. So SEM includes CFA, which is confirmatory factor analysis, as a subset, which is used to assess the measurement properties of latent constructs of factors by examining the relationship between observed variable and their underlying construct. So CFA is a commonly used in psychometrics and social sciences. Then there is a path analysis, which is basically used using some encompass path analysis, a technique for estimated direct and indirect effect among variables in a model. So path analysis allows researchers to understand the direct and indirect path through which variables influence one another. So you can use this procedure for applying the SEM. Then there are two approaches when you are going to use the structural equation modeling. The first approach is CB-SEM. The second approach is PLS-SEM. Uh, Basically, there are slightest difference between CB-SEM and PLS-SEM, and we need to understand this difference in order to correctly apply whether we need to use CB-SEM or PLS-SEM. So CB-SEM and PLS-SEM are two distinct approaches within the broader framework of SEM, each suited for different research context and objective. CB-SEM is preferred when the focus is on testing complex theoretical model with well-defined constructs, while PLS-SEM is more suitable for exploratory analysis and predictions, particularly in a situation where data may not meet parametric assumptions or when the theoretical model is still evolving. So we can understand that in case of CB-SEM, you may have a complex theoretical model, you may have well-defined constructs, and you may have a parametric data set, a normal data set. It's mean you have a maximum number of observation, you have a large sample size in case of CBSM. While in case of PLSM, you may be interested in prediction, you may have a data with non-parametric assumptions, you may have not normal data, and where a theory is still evolving, is still not confirmed the theory. So you can apply uh, the PLSM technique in that case. So here is basically the detailed explanation of each approach. CBSM is based on the covariance based matrix of observed variable. I have previously let you know that what is observed variable. Observed variables are basically indicators, or you can say factors, indicators, uh, you can say the statements that are basically measured using 5-point Likert scale, 7-point Likert scale, 3-point Likert scale, and so on. So whatever statement or indicators that you directly measure using some scale is basically the observed variable. So the CBSM is based on covariance matrix of these observed variables and assumes that the observed variables are continuous and normally distributed. So this procedure assumes that your observed variable are continuous. They are not ordinal. They are not binary. They are continuous, and normal distribution is there. It means your data should be normal. Your observed variable should be normal too. It is widely used when the focus is on testing complex theoretical models. So if your model is theoretically more complex, then you need to use the CT-SEM technique. And you may have well-defined latent constructs also. So if you have well-defined latent constructs, you can use covariance-based SEM modeling. So you may have multiple indicators with latent variables. Then you may have CVSEM aims to estimate the strength and direction of relationship among latent variable and observed variable. So when you are going to have your latent variable, you relate your latent variable with observed variable, you are going to use CVSEM. So let's have an example that basically explain why we are going to use these covariance based methods. Suppose we want to examine the relationship between job satisfaction and job performance. These are basically the two latent variables. Uh, I have explained to you the difference between observed variable and latent variable. So observed variable are directly measured with some statement, with some indications, or with some scales, while the latent variable are the variables which are not directly measured with some statement or indicators. They are basically measured from observed variables. So suppose we want to examine the relationship between job satisfaction, which is a latent variable, and a job performance. It is also a latent variable. Considering factors, now the factors are basically the observed variables. So we may have the factors like salary, work environment, and job autonomy as a latent variable. So each latent variable is measured by several observed variables, like indicators. So we may have a lot of latent variables, and we may measure each latent variable using several observed variables. So CBSM would estimate the direct and indirect effect of these latent variable on job satisfaction and job performance, which are your latent variables, providing insight into how different factors influence these outcomes. So next is basically the partial least square SEM, which is PLSM. So PLSM is a non-parametric approach that does not rely on distributional assumption and is suitable for both continuous and categorical variables. So if you have a categorical variable, you need to use PLSM. And if you have a continuous variable, but your assumptions of normality is not fulfilled, you can use PLSM. So PLSM is basically used when your approach is non-parametric, your normality assumption is not fulfilled for continuous data, or you have categorical data at hand, which means your variables are categorical. They may be categorized into two categories, three categories, five categories, and so on. It is often used when the focus is on prediction or when the theoretical model is not well established. So when you have a theoretical model which is not established and where prediction is involved, then you need to use the PLSM method. So PLSM prioritizes the estimation of relationship between latent variable and places less emphasis on estimating the covariance matrix of the observed variable. So in case of CBSEM, more focus is given on the covariance matrix of observed variables, while in case of PLSM, less emphasis is given on estimating the covariance matrix of observed variable, while more priority is given on latent variables. So as an example, we can see here, uh, consider a study aiming to explore the factors influencing customer loyalty in an e-commerce setting. The latent variable could include the perceived value, satisfaction, trust, and loyalty. Instead of specifying a complex theoretical model with numerous indicators for each latent variable, PLSM allows for more complex approach where researcher can iteratively refine the model based on data exploration and theory development. PLSM would estimate the relationship between latent variable and identify the key driver of customer loyalty and or even in the absence of well-defined model. So here we can conclude that more focus is given on latent variable rather than covariance matrix of observed variable in case of PLSM. Here are the key components of PLSM. I would discuss these key components tomorrow. Let's have brief sessions for today, and let's complete this session for today. Thank you, everyone. We will have the remaining parts tomorrow. We will have the remaining parts for tomorrow's session. We will cover the key components of SEM tomorrow. We will cover the benefits of using SEM, the Smart PLS for SEM tomorrow. So thank you, everyone. Stay safe, stay safe, and stay happy.